And in this episode today, we have a custom mechanical keyboard which is no longer working. We also have a miracle being performed on an Amiga chip which has lost some of his legs. And lastly, we have an Astro Wars Grandstand tabletop game with a floppy joystick. This YouTube Fixers series is all about different YouTubers from around the world, some amateur, some professional, doing what they like to do, which is fixing various different things. So now, in this episode today, we have 3 different fixers. One of them is myself. But to kick it off with, we've got Felipe from MrKeebs.com. Felipe comes from Brazil, so it truly is a worldwide show, this one here, and he loves working with mechanical keyboards. And in this one here, he's got a faulty mechanical keyboard which is not being recognised. And I think the actual cause of the fault is quite an interesting one. It's a very common component, I won't give it away, but in all the videos I've done, I don't think I've actually had this as a faulty component. So here we have Felipe from MrKeebs.
Hi, my name is Keebs from MrKeebs.com. No, I'm just kidding. This is just an homage to our loved Vince, and thank you again for this opportunity. So when Vince invited me to be featured in this series that he's doing, I reached out to a lot of viewers asking if they had anything broken that they wanted fixed for free. And many people did answer that call. And this is one of those broken items that I received from one of my viewers. And I think this is a custom keyboard, a 60% keyboard. If you're not used to the terminology, basically 60% means that it's 60% of the size of a full-size keyboard, the one that you're most likely used to. All right, yeah, as I suspected, it's the built keyboard. It was a keyboard that he built himself. So basically, he bought all the parts, and this is what it looks like. So it's a 60%, as you can see. And he told me that no matter what he does, every time he plugs it in, it's completely dead. It doesn't light up, it doesn't work, and the computer don't even recognize the keyboard. So this is disassembled already, so I can take it out of the case, so I might as well. So this is what it looks like. It has a USB-C connector, and I'm just gonna go ahead and plug it in. There we go. And you can see that we have no Windows notification saying that the keyboard is connected. So I'm gonna try a different port maybe. Yeah, and even on another port, this is not working. And this is exactly what he told me that was going on. So we're gonna have to look a little deeper here. And I'm gonna go ahead and inspect all the traces to see if I see anything suspect. And I think that we can start looking from the USB-C connector down. I think we do have a fuse here, and I wonder if this fuse is good. We're gonna check, but coming from the USB-C port, let's take a look at the USB port itself to see if there are any bend pins. It doesn't look like there are any. And yeah, so coming down from the USB-C connector, oh, wait a second, I do see something suspect over there. Do you see? It seems like there is a pin missing there, doesn't it? So one thing about keyboards is that it doesn't need all the USB-C pins. You basically only need 4 of them on keyboards, which is 5 volts, ground, data plus, and data minus. So I don't think that is the issue we're having here. From that perspective, it looks okay. Yeah, so I found 5 volts across this component here, which I don't know what it is. So let's see from here, where does it go? Let's see if we have 5 volts on the MCU down here. So this is the pinout of the chip. You can see that we have ground here on pin 43, this one here. And you're supposed to be getting 5 volts on, I think, pin number 2 here, which is this UVCC, or maybe on pin 43 as well. So I'm gonna try both and we'll see what we're getting there. And indeed, we do have the 5 volts. I think you can see it there. So we do have 5 volts coming into the board all the way to the MCU. So this MCU is being powered, which is odd. All right, so the next thing I'll try is opening this QMK toolbox here. And this is the tool you use for most of the custom keyboards to flash your firmware. And if I manage to reset this board, we should get a message there saying that this keyboard is now on the bootloader mode. So Yes, so reset is working. You can see that as I press here. And my camera just froze because of that, my side camera. So it is doing something. All right, so I was doing a lot of measurement on this board of camera, and I found something that is really promising. Take a look. And I was looking around this area here. Let me give you a better look. And I was checking that we have two resistors around this area that are marked as 220. Let's see if the camera can capture it. There, I think you can make out that it says 220. So I went ahead and measured the one on the left side, and you can see it shows as open. And when I measured the one next to it, you can clearly see that it says 22 ohms, right? And I got another PCB from another keyboard that I had laying around, and I checked. It also has this couple of 220 resistors here, and you can see that both of them have this 22 ohms resistance, right? And that would explain why we're getting power, but we're not getting the PCB to connect. What I found out is one of those resistors are connected to the data minus signal from the USB port, and the other one is connected to the data plus on the PCB, on the USB connector. So even though we're getting power, we're not getting data from the PC. So what I'm thinking about doing is replacing this guy here with another 220 that I can get from another board. And I was looking around for a board that had that, and I came across this prototype board, and you can see that we have two 220s here. So the next thing that I'm gonna do is try to take out one of those and put it here. But before I even do that, let me see if I can take out this guy from here. So what I think I'll do here is use hot air. Let's go ahead and do that. Before I do that, I'm going to take out all those keys from the keyboard. This is a hot swap board, meaning that I can take them out, so I don't risk burning any of those keycaps or switches. So let me go ahead and do that. When I'm using the hot air station, I like to use this metal plate on the bottom because it helps me with heating the area that I want to heat. I'm going to do 420, and I'm going to have a lower 4 out of 7 airspeed. I'm gonna try and take this guy out. So let's see. There we go. It's out. All right, let's go ahead and remove the one from the donor board. I'm gonna be taking this guy here out. One side's done. Let's see. There we go. It's out. Let me clean this up a little bit. So here's our board again. I'm gonna be adding a little bit of solder on the pads, on one of the pads. I'm gonna add a little bit of solder to that side like that, and try to solder this in place there. And I just realized that this is a little bit larger than the one we had there before. Let's see if this is still gonna work or not. Let me just add a little bit more solder to the top there. It's a little bit too much, but I'm good with that. Let's bring our friend here again. There we go, 21.9 on the left one and 22 on the right. Time for the truth, my friends. Do you guys think it's gonna work? I am hopeful. Let's see. And there we go. It is recognized by Windows. So I think we have a working PCB. Let me go into the key tester feature of this program. If I touch both sides of one of those hot swap sockets, you should see a key being registered there, like so. And you can even see the backlighting on the effect that he had here, that when you press a key, all the other keys eliminate. So I think we have a fix. I'm gonna go ahead and reassemble the keyboard. All right, here it is all back together. Let's go ahead and plug it in. You can see this still working. So the next thing I'll do is something we do a lot on the mechanical keyboards community. And now I'm gonna go and do a typing test on the keyboard. And there we go. All right, and this was our fix today. I'm very glad with how it turned out. And I would really like to thank you again, Vince, for the opportunity. So back to you.
Thank you so much, Felipe. What a nice little fix. Tiny resistor, knocking the whole keyboard out. And I have to admit, I'm jealous with that typing. I've moved on to 2 hands, but I'm still just 1 finger on each hand. So that was pretty impressive and quite relaxing to hear the sounds of that little mechanical keyboard as well. Now, next up, we have somebody that's basically been kind of mentoring me or supporting me since the very beginning of my trying to fix videos. We have Chris from Gadget UK 164. Now, Chris has helped me out immensely over the years, so I'm really happy that he's on this episode here and part of this series. Now, what you're about to witness, in my opinion, is like miracle work. So we have a dead chip from an Amiga, a Commodore Amiga A500 Plus. I'll flash up a little picture of what it looks like on the screen here. Problem is, these chips are getting rarer as the system is getting older, and it's always best to try and fix rather than replace. So here we have Chris. I hope you enjoyed this one.
Thanks, Vince. This time we are looking at a chip from a Commodore Amiga. This is the Ibis Agnes chip from an A500 Plus. Now, this was donated to me from a friend, actually, Sparks UK. You can see here some pins missing. There are 3 or 4 on one side, 1 on the other. So these are becoming harder to find. You can only find them on, faulty systems generally as a spare. You may find them stripped down from a faulty system on eBay, £50 each. Now, because they're becoming rare, and I don't want to spend £50, I've decided I'm going to try and repair the damage to the pins on this. So this is a PLCC chip. It's plastic. You can get ceramic ICs as well. Plastic leaded chip carrier is what PLCC stands for. And the pins come out of the side of the chip, around the side, and they kind of fold in, downwards like that into a little notch on the underside. The reason they're done that way is that when you push it in, it's supported by the underside, and it's the same when you pull it out. It just gives a bit of support there, the way they're folded on the underside. So the best way to, you could just solder a leg. If you broke 1 pin off here, you might be able to just get a little bit of solder onto there and solder a leg. But you know what? Because this goes into a socket like that and it snaps in fairly firmly, they tend to break off. So this is where we need a Dremel just to grind away at the plastic above, so that we can solder a little bit more, get a little bit more solder onto the top of it, and then stick a replacement pin. And I've got a faulty PLCC chip, and I'm just going to cut the pins off right at the top there, and we're going to use an actual pin from this style of chip. Just carefully just slice into those. You can see just 2 have fell off there. You need to be careful when you're using a knife like this. There might not be enough length there. Let's get a couple more. Yeah, there we go. So we've got 4 or 5 there. That's enough to be going on with. So if you're doing something like this yourself, do make sure you're wearing eye protection. So one of the risks with doing something like this is you're generating high amounts of static electricity, and ICs will fail if you get static in there. So yeah, just be careful. But there's nothing we can do with this. There's nothing we can do with this. And I say be careful, there's not a lot you can do to mitigate that. You can wear an ESD wrist strap. But if we don't do this, it's beyond, isn't it? We can't do anything with this the way things stand, so we've got to do something. So periodically, just dab with some IPA, and I can see already I'm starting to expose some of the copper there. Can you see that? So another minute or so of grinding there, and I change the angle slightly. Can you see there now? We've now got some copper exposed there, yeah, where the pin comes out, and obviously on the side of it as well. So that should make it a lot easier to solder something that's more reliable onto. So we've got 2 down there. I'm just going to try and do the 2 that are next to each other here, and then we've just got the 1 on the other side. We can now fit the pins on. So this is the hard bit. I've got the pin tucked into there, the replacement pin that is, and if we just pull this over, obviously I've got to try and straighten it up here. Now before I commit to solder, I'm going to get some solder on there first, but you can see it's banging the right place here. So if I can hold that in position under magnification and get some flux and solder, I could solder a big blob there. We're not bothered if even if it sticks out a little bit, because it's only the sides of the things here that go into the socket. A little blob on the top there is not going to cause any problems putting the chip in and out. So we'll just get a tiny little bit of flux onto each of these here, and then we'll have a go at just putting some solder there. So I'm using a separate magnifier here. You can't really see what I can see, but you can see from a distance. So let's just get a little bit of solder there. See that? A little blob. And we got a little bit on those too, I think. Yeah. And we'll just do the final one now. There we go. You can see a little blob of solder there. A little blob of solder there. That end is just a ground on the end. It doesn't go to a pin. There is only one pin missing, which you can see just from that dot there, and then those ones there. So I'm going to try and stick one of the pins on off camera. I'll show you that, and then we'll revisit and then just do the rest. There we go. So you can see it's on there, and it's not quite straight. It's going to be all right. That I'm happy with that. I would leave that as is. We've got a couple more pins done there, so we've just got the two over here to do now. I don't like doing this, it's kind of barbaric, isn't it? You know, but what can you do? This is bin fodder, unless we try something, you know, unusual, unorthodox. So I'll try and do this next one on camera. The key is having small hands, actually, small fingers. You've got to try and hook it on there, like that. That's it. Can you see that? That's hooked on. And then hold it with the finger like that. Flip it over. And then try and align it. It's very hard to do this on the camcorder. Yeah, make sure it's not short into the pins either side. Get a nice big blob of solder on your tip, well, fairly big. Bear in mind we've got flux and solder and stuff on the point that we're going to solder onto there already. And then be very careful, and then just try and connect it up. Probably have to redo that off camera, but yeah, it's at an angle, look. I'll redo that off camera, but you can see the principle in general. You can see we've got some good solder points there. Yeah, there's a bit of unevenness here. Now, you could further deal with that by, you know, holding there with something that's, you know, not your finger, and then just adding a bit of solder onto the outside, because that would pad it out a little. But you know what? The socket is going to be good enough to take into account the subtle differences there in the height. And the straightness, it's not too bad, but yeah, I bet that works. Let's go and give that a try. And you could finish off here by actually filling these with, I don't know, black silicone or something, or some filler, and paint the edges black. You could do that, but anyway, I'd rather leave it like that, just in case a pin breaks off. It's then easy to solder back on again. So to get this type of IC out of a socket, you can use a PLCC extractor. We'll give it a go. Let's just see. Yeah, look's coming out, look, it's coming out fairly easy. And put that to the side. So there's a dot there in the actual plastic. That indicates pin 1, and there's a 1 there. So let's just carefully try and line this. Got to be careful, because obviously you don't want to damage the work you've just done. Is it going to go in? Let's switch it on. And we've got a green screen. Now that could indicate one of the pins has just broken off, so we'll take it out and inspect it. No, all the pins are okay. So it's perhaps because one or two of these are sunk in a little bit that it's not making a very good connection. So I might just tin them with a bit extra solder. We'll try it one more time for good measure. If I still get a green screen, I'll go away and just tin them up a little bit. Woohoo! Fantastic, it works. I literally just reseated it. So I think it's perhaps because one or two of those pins have just sunk down a little bit on one side, and just reseating it seems to have solved it. But you know, that's £50 Agnes saved. The main purpose of me showing you this is that sometimes you get a rare, super rare IC, a pin breaks off, and it can be a nightmare trying to solder a pin back on. Anyway, hopefully you found that interesting. Back over to you, Vince. Thank you.
Wow, amazing soldering there. It's, again, when you're watching it on a big screen, it looks easy. It's not easy. These chips are small, and you have to be really delicate with that Dremel. But you see there, what a lovely way to fix that chip. So, yeah, fantastic job, Chris. Next up you have me, and I'm going to be working on an item that I previously fixed in one of my videos. Now this item has been working fine since I fixed it, but recently the joystick has gone all floppy. So what we've got here is Astro Wars, a grandstand game from the 1980s. This was sent in by Lee quite a few months ago, and it has actually got some use. Interestingly, my wife occasionally plays it, which is unusual for me to see. Apparently her brother had one of these back in the 80s. So, but anyway, my son was playing it, and look what's happened here. I don't know whether he was being a little bit over heavy-handed with it, but this should centre back into the middle. So this is the only thing that's wrong. It's not going to be anything major, but rather than just replacing the whole thing, let's see if we can actually fix the joystick, because quite a few of these machines are probably going to have the same problem after being in use for the last 30-something years. So let's take it apart and see if we can get this centering again and work out what the problem is. So if we flip it over, we have 7 screws to undo. Right, so we don't have to worry about anything here, we're just working on this little joystick. So undo the 2 screws, and I'm just going to unsolder the 3 contacts from this ribbon cable, because this is already short, because I think I had to resolder this one last time I fixed it. So I'm just using my little engineer solder sucker. It's nice this, because it's got a little silicone tip, so it really gets around the solder. It's quite a well made little tool. Right, so this is out now, so we can have a nice look at it. Well, I can't see any springs or anything on there. I think we're going to have to unsolder it from here to get it out the actual board. Done now. I'm just going to start easing it off, see if it will come or not. I might need to take a bit more solder off. Oh, here we go. Excellent, that came off nice. Right, I can't put it on the wrong way, because you can see we've got 2 holes here and then 6 holes over this side. 6 and 2. Right, okay. Well, we're still none the wiser, so we're going to have to take off this metal casing. It's got 4 little tabs here, here, here and here. Okay, so these are the contacts. This little bridge here moves along and will contact different pins to different pins. So if it's there, it's going to contact that pin to that pin. If it's here, it's going to contact that pin to that pin. And if it's here, it's going to contact that pin to that pin. And the same on that side there. So I suppose if you were having a problem with left and right, maybe you could clean it up here and also squeeze these little ones in together, and then they would make a better contact on here. But I'm not going to touch any of that because it's working perfectly. Okay, what have we got here then? Right, that goes on there, and then that goes on here, like so. Okay, so that's what's moving those little bridges here. Right, okay, I can see a little ball shoved up in here. And the middle one here is like a mini ramp, isn't it? Can you see here? It goes down and back up. A skateboard mini ramp, you know. Right, so that ball must travel in there, and that's what will... Now, how will that make it go centre, though? Why would that want to go to the centre? Let's see if we can pop the ball out. Yeah, that's loose. Okay, I can see a spring in here. Let's make sure we don't lose that. Maybe we can just elongate the spring. Okay. I can see more. Here it comes. There we are. Right, okay, that spring is completely and utterly broken. So that's why it's failed, because there's no spring putting pressure on the ball. That ball probably needs to be sat on the very edge of here. But because it wasn't sat on the edge, because it was pushed in, it wasn't centering. So we need to get ourselves another spring, because that's all snapped up. So the spring I need is 1.8 millimeters in diameter, which is absolutely tiny. I've had a look online, and the ones that the kits and stuff are all far too big. The kits with all the different springs in. And when I looked a single listing of springs, they seem to have like 0.8 millimeter wire, but the actual diameter of the spring seems to be 3 or 4 millimeters. So I don't know how common a tiny spring like that is. But I've had a bit of a thought, and what I'm thinking is the smallest springs I've got in the house are these. You know, on your watch, you know, when you have the bits that clip in the bracelet to the actual case of the watch, you know, these bits that go through here. Yeah, you know, well, you can't see it here because they're hidden, but the bits that go in here to there, if you have a look, one side of them has to be pushed in to allow it to, well, actually, sorry, both sides. Okay, yeah, both sides go in to allow it to, you know, fit into the watch and then spring out again. So now the spring in there, I think, although it's going to be too small, as long as it's putting pressure on the ball, and as long as it doesn't work its way sort of past the ball, which it's not going to, then I've got a feeling that that might work. Now obviously I don't know the length, but I'm just going to take one of the springs out, put it in here, and maybe cut it a few millimeters just past here, and then when I push the ball in, it's always going to be under tension, and it's always going to want to push out. I don't want to do it too much, because you see it's only in plastic and the ball would come shooting out all the time. So I think a few millimeters past there will do. So let me get one of these out. There we go. Yay! There's our spring. Right, so well, it certainly fits in there. So what I'm going to do is I'm going to cut this side, but then I'm going to put the bad side in, so we got the nice part of the spring against the ball. I think that will work. So if you were to get maybe a 2 diameter spring bar, then that might give you the perfect spring. There we go, so I'm just flush with the end of it now. There we go, I think that's better. Right, I think that might be it. I'm going to put it back together and see. Oh, looks like it might work. Here we have it all finished. You can see that it is fully centering, even if I do it really slow and let go, slow and let go. In my opinion, it feels more sluggish than it did before, but my wife's had a go on this and she thinks it feels better because it's tighter, it's not as loose. But for me, I think I preferred it before. But you can see now, it's working better than it did before. Yeah, let me just turn it on. Right, I'm just doing this one-handed. So that is it. Not the best fix in the world, but still a fix. So there we have it, and it's still working now. So the spring is still doing its job, which is fantastic, and costs next to no money as well. So it might not be as good as new, but it's better than being broken. So that is it for this video. I hope you enjoyed this particular episode. If you've missed the previous 5, think about checking them out. If you enjoyed watching Felipe and Chris, their channels will be in the description down below, so you can head over there and subscribe to them. I will see you very shortly in the next one. Take care, everyone.